So hello students, so this is polarization of light. So this is the last part of wave optics. Okay, so wave optics has three parts. That is interference, diffraction and polarization. So in my last videos I have explained your interference of light as well as what? Diffraction of light. Now come to polarization of light. Now what is polarization? So polarization means what? To restrict the vibrations of light in a single plane, in a particular directions. That is called what? Polarization. Now light is a transverse wave. Transverse wave means what? When a wave travels, the particles will be medium, vibrate in a direction normal to propagation of the wave. Suppose light travels in this direction, its vibrations will be what? In this direction and in this direction. So one is in the plane and one is normal to the plane. Now out of these two vibration, one vibration you have to block. That means light will vibrate only in single plane. That is called what? Polarization. So you can say that what is polarization? That is the process of restricting the vibrations of light. The vibrations of light in a particular direction or plane is called polarization. Okay, polarization. For example, you see, suppose light traveling in these directions. Okay, light traveling in these directions. Its vibrations will be what? In these directions and in this direction. Now out of these two directions, one you have to block. Okay, that means it will vibrate only in this or only in this. That process is called what? Polarization. So polarization requires what? Transverse nature of light, transverse nature of wave. So it requires transverse nature of wave, and hence light can be polarized, but sound cannot be polarized. Okay, sound cannot be polarized because sound is what? Longitudinal wave. And in longitudinal wave, the vibrations of the wave in the direction of propagation of the wave. So suppose sound is longitudinal wave, sound is traveling in these directions. Okay, so vibrations also in the same directions. Okay, if sound travels in the directions, the vibration also in the same direction. So if you block the vibrations, sound itself will be blocked. So you cannot polarize sound. But in light, if light travels in this direction, vibrations will be along this or along this. So if you block one direction, other will be there. So light can be polarized, but sound cannot be polarized. So we'll see how can we polarize the light. Let's see the methods of polarizations. Methods of polarization. So there are several methods. One is by selective absorption. That means we have two components. One component we absorb. Okay. By observing one component, other component is allowed to pass. So by selective absorption, polarization can be done. By refraction and reflection. We'll see. Okay. Then by scattering. So these are the main three ways by which we can polarize light. Okay, by selective absorption, by refraction and reflection, and by scattering of light. So we'll see how can we polarize the light. By selective absorption, for selective absorption we use some crystals like calcite crystal, tourmaline crystals. Okay. So let me show you. This suppose a crystal. Okay. This suppose a crystal. So this is the optic axis. Optic axis means what? The axis through which light can pass. Means light can pass only through this axis. That's why it is called optomet light. So here suppose unpolarized light incident. Unpolarized means what? It has both the components of light. Okay, here you see. One component I have shown by arrow mark, another by dot. So arrow mark means what? That is vibration perpendicular, vibration parallel to the plane. And dot represents what? Vibration perpendicular to the plane. Okay. So this is what? Unpolarized light. Unpolarized light. Now here you see, this is suppose the crystal, okay? This is suppose the crystal. This is the tourmaline crystal. Tourmaline crystal, okay? This is used, okay? So this is suppose the crystal. Now this is the light traveling along these directions, okay? So there will be two vibrations. One vibrations like this way, which is parallel to the plane of the axis, and another vibrations like this way, which is perpendicular to the plane of the axis. Now this vibration, which is parallel to the plane of the axis, that can easily pass because it is parallel to the plane. But these vibrations, which is normal to the plane of the axis, will be blocked. So ultimately, here you will get only these vibrations, which is parallel to the axis. So this is called plane polarized light. Plane polarized light, because it has only one vibrations. So what is plane polarized light? Plane polarized light means what? The light which vibrate only in a single plane or a particular direction. That is called what? Plane polarized light. So how it differs from the unpolarized light? Unpolarized light has two components, but plane polarized light only one component, and that's why intensity also half. Suppose its intensity is I, intensity will be what? I by 2, because here it has two components, but here it has only one component, so intensity will be halved. Okay. So this is polarization. It has only one component. Now I define polarizer and analyzer. Polarizer and analyzer. Now polarizer means what? Those crystals or substances used to produce plane polarized light. Okay, plane polarized light. Plane polarized light. They are called polarizers. The analyzer means what? Substances used to analyze the light, whether it completely polarizes or not. Because just by seeing we cannot determine whether light polarizes or not. Okay, we have to examine whether light completely polarizes or not. So the substances used to examine, we will see how. Okay, the substances used to examine whether light polarizes or not, they are called analyzer, and the substances used to produce polarized light is called what? Polarizer. So we will see here. See, this is suppose a crystal. This is unpolarized light. Here means it has both components. Now here you have only one component. If light completely polarizes, okay. So this is plane polarized light. Plane polarized light. So this is called what? Polarizer. Because it produces what? Plane polarized light. Now here you use another crystal. Okay. So this crystal we call analyzer. Now you see, if the plane of polarizer and analyzer are parallel to each other, then the light which pass through the polarizer, that also will pass through the analyzer. So here you will get maximum intensity. Maximum intensity. That means here if intensity is suppose I, here it will be what? I by 2. Here also it is what? I by 2. Now what we'll do? Now we'll rotate this one. We rotate. Now if this parallel, this light will come through, intensity same. But if we rotate like this way. Now in this position you see, in this position, this light will be now blocked. So this cannot pass. So in this position, intensity is maximum. Now if we rotate, here intensity will be 0. Again here intensity will be maximum. Here intensity again 0. See, so in one complete rotation, if intensity is twice maximum and twice 0, then you can say light is completely polarized. That means in second situation, here you see if the axes are parallel, then here intensity of light is maximum. But if your axes are perpendicular to each other, here you see this is plain polarized light, here now you draw it like this way, it is perpendicular to each other. Okay, now in this case intensity will be what? 0, because here this is parallel to the axis, but axis now is perpendicular, so here there will be no light. Okay, there will be no light. So here intensity is suppose I, here intensity will be I by 2, here intensity will be what? 0. So we can say that by rotating the analyzer, you can say whether light polarizes or not. So if in this position, parallel position light is maximum and in perpendicular light is 0, that means light is completely polarized. But if in parallel light intensity is there, in perpendicular also intensity is there, here you are getting intensity suppose. In that case light is not completely polarized, because under this condition if you are getting light, means there is a presence of what? Perpendicular component that will pass. So you can say that light is not completely polarized. So by rotating the analyzer, we can examine, we can find out that whether light completely polarizes or not. So in one complete rotation, if the intensity of light transmitted through analyzer never reduces to 0, then light is not completely polarized. Okay. Now here I will define a very important law, that is called law of malus. It's very important. Law of malus. So every year one numerical come from this part in NEET as well as JEE. Okay. Law of malus. Now what is law of malus? What we have seen, the intensity of light transmitted through the analyzer depends on what? The angle between the plane of polarizer and analyzer. So here you see, if the angle between them is 0, means the axes are parallel, intensity is maximum. And if they are perpendicular, intensity is 0. So you can say that intensity of light transmitted through the analyzer is proportional to what? Cos square theta. Or it is equal to I naught cos square theta. So this is called law of malus. So here what is I naught? I naught is the intensity of light. This is I naught here. This one I consider I naught. Okay. This is I naught suppose. I naught. So intensity of light incident on analyzer. Okay. Analyzer from polarizer. And I dash is the intensity of light transmitted through the analyzer. Okay. And theta is the angle between the plane of polarizer and analyzer. Okay, so what we have seen that the intensity of light transmitted to analyzer depends on the angle between them. Okay, if the angle is 0, means they are parallel, cos 0 1, intensity is maximum. If they are perpendicular, that is theta is 90 and cos 90 is 0, the intensity will be 0. So this is law of malus. Okay. Next one is polarizing angle. Polarizing angle or Brewster's angle. Brewster's angle. So you consider a transparent sheet. We suppose a transparent sheet. Okay, transparent sheet. So here you have to remember, okay, this is experimentally obtained. So when light incident at the polarizing angle, this is called polarizing angle or Brewster's angle. Okay, it is IB suppose. Now when light incident at the Brewster's angle, then what happens is light, this is suppose unpolarized light. Okay, this is suppose unpolarized light, means both components are there. Both components are there. When light incident at the polarizing angle, what happens? The reflected light is partially polarized. Okay, or plane polarized. So it is plane polarized and transmitted light will be partial polarized. Partial polarized means what? Here both the components will be there, but its intensity will be less than this intensity. So here it is plane polarized. Plane polarized. Here it is partially polarized. Okay, partially polarized. Partially polarized. So this is the angle of refraction here. So this is, we know the angle of incidence equal to angle of reflection. So that also IB. So here you have to remember that when light incident at the polarizing angle or Brewster's angle, then what happens? The reflected light is plane polarized. This is experimentally obtained. Remember, the reflected light is plane polarized. The refracted light is partially polarized, and the reflected and refracted beam are perpendicular to each other. This angle is 90. So this point you have to remember. That is, when unpolarized light incident at the polarizing angle, polarizing or Brewster's angle, then what happened? Number one, the reflected light is plane polarized. Secondly, the refracted light is partially polarized. And thirdly, the reflected and refracted beam are perpendicular to each other. Okay, so this point you have to remember, the experimental obtained when light incident at the polarizing angle, then what happened? The reflected light is plane polarized, means here only one component of light is there. Then refracted beam is partially polarized, and the reflected and refracted beam are at 90 degree to each other. Okay, so now you see, if this angle is 90 degree, then what happened? This plus this also 90, because total is what? Total is 180. So you can say that here IB plus R is equal to what? 90 degree. So here IB is what? That is Brewster's or polarizing angle. Okay, polarizing angle. And R is what? Angle of refraction. So this is also one of the important relation. So here another relation we can derive you see, suppose the refractive index of this material is suppose mu. Okay. Then you apply Snell's law here. Mu is equal to what? Sin I by sin R. You know that? Mu equals sin I by sin R. That is law of refraction. So here what is I here? I is what? Brewster's IB. And what is R here? From here you can see IB plus R is what? 90. So R you can write 90 minus IB. So this will be what? Sin IB by cos IB. That is 10 IB. That is 10. So mu equal to 10 IB. So this is called Brewster's law. This is called Brewster's law. What is Brewster's law? You can say the refractive index of the transparent sheet is equal to what? Tangent of the polarizing angle. So mu is equal to 10 IB. So this is called what? Brewster's law. Okay.